Hi. In this video, we're going to look at another explosion type problem in momentum conservation. So let's get started. Charlie, who's 65 kilograms, and Hannah, who's 48 kilograms, are both floating on inner tubes at a lake during a summer camp. As a not so subtle communication of romantic interest, Charlie kicks Hannah's tube so that it moves to the right at a speed of 2.5 meters per second. Would Charlie's motion be affected in any way? If so, how? So we know that if you exert a force on something, then Newton's third law says that there's an equal and opposite force exerted on you. And so if Charlie kicks Hannah's tube, he's going to get a kick back. He gets a push back as a result. So he's going to move backwards while his Hannah's going to move forward. So I've drawn that here as a before and after sketch. So I'd encourage you to do the same as you take notes here. And then we're going to write our equation for momentum conservation, which basically just says that the momentum of the system doesn't change. So whatever momentum you start with, I'll say total initial momentum here, will be equal to the momentum that you end with because it doesn't go away. As long as there's no friction, there's no outside forces, then the momentum is conserved. It doesn't change. The momentum beforehand is zero because they're at rest together here on the water. The momentum afterwards is going to be a combination of Charlie and Hannah's momentum. We add their momenta together to figure out, what their total momentum would be. So that's going to be momentum is mass times velocity for each one. So I'm going to say mass of Charlie times velocity of Charlie plus the mass of Hannah times the velocity of Hannah. Okay, so now I can start to put in some numbers of things that I know to be true here. So we know the initial is still zero. The mass of Charlie is 65 kilograms. We don't know Charlie's velocity. We know that the mass of Hannah is 48 kilograms. And the velocity of Hannah is, at the end, it says 2.5 meters per second up here. So 2.5 meters per second. So I can start putting in some numbers into my calculator. We're going to do 48 kilograms times 2.5 meters per second. 48 times 2.5 is 120 kilograms times meters per second. We're solving for the velocity of Charlie, so we're going to try to isolate this quantity right here. We need to get rid of the 65. We need to get rid of the 120. We're going to start with whatever's farthest from our variable that we're solving for. We're going to move this and undo this addition. We have to do the same thing to the other side to keep it equal. So we'll do minus 120 on both sides. That will get rid of that. So negative 120 kilogram times meters per second is equal to 65 kilograms times the velocity of Charlie. So now we're ready to divide by 65 kilograms on both sides. All right, and so when we do that, we get the velocity of Charlie is equal to, and I'll put this into a calculator, 120 divided by 65 is 1.8. We'll round that to two significant figures. And this is a negative value, so this is negative 1.8. Kilograms are canceling each other out here, and so 1.8 meters per second in the negative direction. That is the velocity of Charlie. So just check to make sure that makes sense. It's negative because he's moving to the left as a result of pushing Hannah to the right. Hannah got pushed at a speed of 2.5 meters per second. Charlie's speed is lower, but he's also bigger. So they have the same momentum, just in opposite directions. So that's all I've got for you in this video. Remember, how you do anything is how you do everything.